In this section, we'll look at extrema. So extrema are points that are interesting on graphs of functions, and there are several different kinds of them. So we'll kind of go through the mathematical characterization a little bit more in class. So the kinds of extrema that we'll be really interested in finding are places such as this point here. So this point is a local maximum because its y value is bigger than y values of points that are nearby to it. Similarly, you could have a local minimum, something like y equals x squared has 1. So there are other kinds of extrema. For example, if there's a point at which the derivative is undefined, this point is still a local min, even though the derivative has something strange going on there. So these kinds of points are the kinds of things that we're going to be considering. And we'll kind of characterize more thoroughly in class what precisely mathematically identifies them, but for the purposes of this video, we're going to do this a little bit inductively. Okay, so the first question here, problem gives me a graph, and I'll just kind of make a rough sketch as to what it looks like. Something like that. And then they've identified for us this point right here, and this point has coordinates 0, 0. It's at the origin. And the graph of this function is given by the equation x squared over x squared plus 1. And what we're interested in is to find f prime of 0. Okay, so to find f prime of 0, let's first find f prime of x. So f prime of x is, well, we need to do the quotient rule here, so it'll be the bottom thing times the derivative of the top thing minus the top thing. Oops, top is x squared. X squared times the derivative of the bottom thing, which is, in this case is also 2x, because the derivative of this constant 1 is 0. And then we need to divide that by the denominator squared. Okay, now in this case we probably should go ahead and simplify this expression a little bit. And go ahead and start getting in the habit of doing a little bit more simplification than we did in previous sections. So I'll go ahead and distribute on that first term. So I'll get 2x cubed plus 2x. And then over here I'm going to get minus x cubed. And this will all be divided by x squared plus 1 squared. And then go one step further. 2x cubed minus x cubed is just x cubed. So we've got x cubed plus 2x all divided by that stuff. Okay, so that's f prime of x. We were interested in computing f prime of 0. So all I've got to do is plug 0 in for x here. And then just compute the arithmetic. And so we get 0 there, 0 there. That puts a 0 on top. And in the denominator, we've got 1. And so this is 0. Okay, so in this case, we get 0 is our value of f prime of 0. And if we kind of think back at the problem we were asking, that should kind of make sense. Because, and sorry, this is going to go over the coordinates there. The slope of the line that goes through that red point, so the slope of the tangent, looks roughly to be 0. It's definitely a really small number. It's not really positive and it's not really negative like that, but it's something roughly around 0. Here we got exactly 0. So what that tells us is that this blue line is actually a horizontal tangent. Now it's a little bit off in my picture, so kind of ignore that. But we found a sort of interesting property that this local minimum happens, and it just so happens that at that point the derivative is 0. Okay? So this is a theme that's going to keep coming up over and over again, and we'll see a little bit more about this in class. Okay, so now you have two problems to work for pre-class, one of which is very, very, very similar to this one, and the other one, the function's a little bit different, but basically the idea is the same. Take your derivative, plug in the x coordinate of the point that you're interested in, and see what you get.